Spacelab Marshal Ops. We've got you for 48 minutes through Tidris.
Okay, Bill, we got you. And you can...
And we're dropping in and out here. Hopefully you'll copy this. We've got live TV from the payload bay, and we're going to be coming inside and visiting with you for a while.
Okay, that's fine. We got camera number, no, I don't know. Camera number 2 is set up down here. Camera 1 is set up with a little First Physics impromptu experiment, so you guys can switch back and forth at your leisure in here.
Okay, we copy. Real good, Byron. And Spacelab, are you recording something on VITR1?
I believe we are, yes. Ulf says he's stealing a couple of inches. Hey Bill, we're just starting Owen here on blister cardiography, so if you want to get some of this on the tube, you might want to switch in here pretty soon.
And Spacelab, we've lost temporarily downlink lock. We'll be with you in a moment.
Marshal Ops Spacelab, you guys have any live TV yet?
We're still live outside, Byron. We should be inside momentarily.
Okay, if you want to get into the blister.
Byron, we also noticed that you're recording camera 1 on the VITR number 1. I guess you're getting some SVM data, is that right?
Well, yeah, you can take a look at it. I'd prefer you come inside to camera 2 first, though, because we got Owen doing the ballistocardiography now.
Okay, real good.
Go ahead, John. You just stopped there. I heard all you said.
Okay. Now, if the end plate does not work, then install 329 front feed plate and proceed with 329C.
Okay, roger. I copy that. Understand.
Further instructions are, we hope very much you can accommodate Isidora's run, but if not, then there are further changes to procedure 329C.
Okay, understand. Well, I'll get to work and start setting up the equipment unless there's something else that is going on here. I need to take a look at the flight plan.
Okay, but just one last piece of instruction. If you set up 329C, it is essential that point S, sugar, 3 is omitted.
Understand. Omit point Sierra.
And the feeding of liquid onto the end plate is done as before.
I understand.
Furthermore, don't proceed beyond step D or... of course, without allowing for break.
I'm sorry, I missed part of what you said, Isidoro. Continue the iso rotation, you say, and you'd like to grow some more?
Yes, go to iso rotation.
Okay.
And spacelab, we're about to go LOS, but the recorder is running, and that was a really terrific show, Brian. We're delighted.
Okay, that's super, Mike. Well, I'll continue to try some more, and I'll put it on tape what I'm doing.
Real good, and there's lots of tape, so keep them rolling.
Okay, we'll go.
And we'll see you at 6+02 at Guam.
Okay, and for the tape recorders, I've got the front plate setting of 23.8 and 20.8 right now, and I'm going to 33.0 and 29.0. Speeds are 0.2 on the front and 0.19 on the reservoir right now.
Real good, Brian. We copy those notes. Real good.
Okay, I'll be putting it on tape here. growing, it's now steady here at about 33.6, 29.5, and we're going to go ahead and try and grow a longer one here. It's kind of difficult to see the transition. I'm going to back out zoom out the camera a little bit so we'll be able to see exactly where the zone is. Okay, we repositioned the camera and now we're starting again trying to drive to 38.0 front plate, 33.5 rear plate, reservoir. Okay, stop here a minute. It looks like we have just about 90-degree contact angle. Okay, I'm going to continue now. Okay, problem is that we've just about run out of travel on the fluid physics module. Oh, I guess I have a little bit more. And be advised, just to make sure that you understand what's happening, that the Perspex plastic is on the top of our screen, and where the two light reflections come down to form a node is about the point of where the fluid column starts. So it's what you're seeing here is not an entire fluid column. Let's see if I can get some more. Okay, we're going to try and go to 43 and 38.0. Okay, the ratios of 0.9 is exactly perfect, and still looks like a really nice cylinder to me. Okay, 5 more millimeters before my reservoir. I think I have maybe 5 more millimeters before my reservoir. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going to try and go to 43 and 38.0. Okay, we're going I think I have maybe 5 more millimeters before my reservoir. I think I have maybe 5 more millimeters before my reservoir hits the rear travel. Okay, even though there are tracers in there, they're not, it's not obvious that you can see them now. I see some bubbles and that's about it. Okay, we're now going to a 48 millimeter long column at 42.5 reservoir setting. Here we go. Okay, let's see what we have here. This is a 48 millimeter long cylindrical column. And we're taking pictures once every 10 seconds or so. We use about 120 frames. And I am really at the end of the travel. I could go maybe 2 or 3 more millimeters, but that's about it. I'm going to put the tape recorder in standby now and stand by here a couple minutes until we get contact. Okay, I'm going to mark one frame here with the program mode. Starting a speed 5 to 10 RPM on ISO rotation. And we're ready, go, mark. Okay, we'll start over again here. I didn't have the camera going. 60 frames. I've taken about 200 frames since I've started. You see no instabilities here, so it's awfully nice. Okay, I think we have 10 RPM now. And remembering the length of the column is only from the plastic, which is separated by, you see the two reflections on the videotape here. Be more visible in the Vinton camera. Okay, we're about to speed up now to 15 RPM. Mark one frame. Here we go. There's definite C mode. Camera slow down to 12 RPM now. Okay, it looks like we still have a C mode here. Slow back down to 5. Okay, we're now slowing down to 5 RPM, and I want to check the shape again. It looks like we may not be quite cylindrical. We're going to inject a little more fluid. Going 41.5 on the reservoir. It's too high. Okay, that looks a lot better. got some sort of an oscillating wave in there. Okay, we'll let it get steady here again at 5 RPM and do a spin up to 10. Do a spin up to 12. Okay, I'm going to mark the film. Take 50 frames here. Here goes the camera, and here comes rotation start. Got a 0 ramp speed. There's C mode developing. Okay, we're still continuing now. We're at, must be at 12 RPM. I'll go up to 13. I'm going to mark the film. Here comes the film mark. 50 more frames. Camera start. Station start mark. Okay. Looks like we're losing fluid down over the perspex column, though, to the heating end plate. It looks like somehow we went over. Means that somehow we surpassed the contact angle of 90 degrees. It looks very nicely attached, however, on the opposite end plate. Go to 14. Stop the camera. Mark the frame. Start the camera. Here's 14 RPM. And it looks like we're definitely losing fluid now onto the back end plate. Looks like it's very slowly being sucked off onto the feeding end plate. We'll increase the speed now. 17. Ready, mark. I think we're about to have a break here. Okay, well, I'll try and rejoin. Yeah, unfortunately I wasn't quick enough to get the cine. Okay, now we're going to start the place traveling together. Okay, coming forward at half millimeter per second. And we'll speed it up now to 0.9. Oh well, that's life in the big city. Problem is that the contact angle exceeds 90 degrees over the edge as we start spinning in the C mode, and the fluid just leaks right around the corner. And no. Stop the tape recorder for a few minutes. Plate and 7.4 for the reservoir, and I'm just going to drive the both of them together until we get contact.
And Byron, I know that you're recording.
That's firm, Mike.
Okay? Real good. If you have something exciting to show us, we might be able to arrange some real-time down like this task.
Okay, well, the only thing exciting would be the merging, and that's going to be on television, too. Okay, we're at 2 millimeters now. 1 millimeter. So I'm about ready to go to cine mode here. But that happens in a hurry. Okay, it's on the TV camera, but not on the movie film again. It looks like it almost jumped the gap. Looked like there might have been some electrostatic effect there. The one thing, Roger, go ahead, Isidore.
Just to ask you if the liquid is still attached at the edges.
I'm sorry, say again, please.
Is the liquid attached to the edges of the neutron cone plate?
Negative. The liquid, well, it's hard to tell. There is a discontinuity. There's a bunch of liquid that has spilled over onto the actual rear end plate, but it looks like the liquid is now attached. It looks like we have sort of a John Padet catenoid type shape sitting here.
Roger, I copy.
Okay, and even with the warning, I still didn't get that on cine mode. It happens extremely rapidly.
Sounds like a good thing we have the video there.
Roger. The interesting thing is that there doesn't seem to be any type of hysteresis or effects when you form a catenoid type shape and then let it sit there. The liquid doesn't seem to withdraw off of the wetted surfaces around the end plate that we'd like to see.
Byron, 61 PI.
Oh, go ahead.
I would like you to start at 5 p.m. ice rotation to check for the edge attachment of the new made end plate.
Okay, I'm sorry. You said 5 RPM and then I missed the rest of it. 331 PI, please repeat all after 5 RPM, ISO rotation.
The point is for you to verify that there is a sharp liquid edge at the end of the feeding end plate, and for RPM, nice rotation.
Okay, I understand. We have 5 RPM going here.
By the way, I think you could see the 5 RPM all over because it cannot damage the zone and it will help a lot to interpret the field afterwards.
Okay, I copy.
Do you think that cylindrical columns are still attainable with the present configuration?
Well, I think we need to make some new end plates. You need to have end plates that have actually a very sharp shape so that rather than coming across 90 degrees that they actually are beveled back to the inside so that you have a much higher contact angle if the liquid tries to go over the edge. It would also, I guess, be nice to have some sort of a true anti-wetting thing, maybe Teflon with a metal plate built up on it with a bevel cut into the back of it. That might help.
Byron, yes, that sounds like a terrific idea. Just earlier this morning we went through a potential redesign in which each end plate has a pedestal standing on it with a sharp-edged disc to give a precise contact line at various contact angles.
Roger, I think it's possible to do that, Mike. I mean, I had a nice cylinder up here with 90 degrees of contact angle on the front edge of the disc. The problem is, as soon as we tried the C mode, it went around the edge and saw a 0-degree contact angle and said, oh, I'm going this way.
We copy, Byron. Right.
Okay, well, I think that's all I can do here, so I think I'll go ahead and start cleaning up my ton of oil.
Byron?
So go ahead, 331.
I would like you to prepare for 327 mixing with the existing filling plate, of course, once it has been cleaned, and it's a special rear plate to be able to have the TVs downlink at 750 oncoming AOS.
Okay, was that the 750 or 715? And we're ready to go here.
Okay, that's fine. Maybe you could give me some commentary on the spreading of the liquid across that improvised end plate as you throw the drop.
Okay. Okay, here comes the bubble out, and it's coming across. And there's some air. It's forming almost a cone shape with a very pointed edge with that air, I think. Okay, it's coming out some more now. It's still a little bit pointed. Now it's rounding out nicely. 1 centimeter. I better stop it. We've got a pretty good bubble here.
That 1 centimeter, is that the diameter or the height of the drop?
That's the height from the plate to the top of the bubble.
Okay, maybe you can very cautiously continue to grow the drop. Are you doing this manually or with the FPM feed?
I'm using the FPM to fill it out there.
Okay, Byron, I think you might get better control if you use the manual drive.
I think you're right. Okay, you're not too concerned about volume, huh?
No, I think we can measure the volume of the image.
Okay. Okay, well, I'll go ahead and put some more fluid in. I think you're right about the manual control. Would you like a very big drop here? 1.5 centimeters high now.
Okay, can you estimate the contact angle of the drop? Has it reached the edge of the disc yet?
I'd say 45 degrees.
I mean, 45 degrees at the edge of the disc. I think you can increase
I'll have to back the plates out some more. And for my canes, it looks like the bubble's holding nicely here. Oh, wait a minute. No. It leaked over the edge. Okay, it went around the undercut edge, and it's now back on the flat metal end plate over.
Okay, I'll read you that it overspread the edge of the disc. Could you give us an estimate of what the angle at the edge of the disc was when this happened, over?
I haven't changed anything. I thought it was about 45 degrees.
Okay, and you still have a drop of about 1 centimeter height. If so, then you should start advancing it and try to achieve spreading on the end plate. Over.
Okay, good, here we go. CPAC, it looks like maybe it's going to run this time. We've got the dep ready, yes, and the PCF parameter that you wanted is already 69 equals 1.
Roger, thank you, Owen.
Transmission scratchy is pretty scratchy in my earpiece, over.
I was acknowledging.
Roger, I understand. I just wondered if my transmission was satisfactory.
Yes it was. I can hear you plainly.
The battery voltage at 43.2 is just barely above the minimum. I'm not sure whether the software will eject when it gets to anything below 43.0 or not.
No problem with the battery, Owen.
Okay. There it goes again, Mike. You're absolutely right. There's definitely electrostatic effect here. It jumped across the gap about 7 or 8 millimeters to form the floating zone, over.
I read a count of 7 or 8 millimeters. That's spectacular.
Yes, it really is, and I missed it on Cine, but it's on video. CPAC or martial ops, can one of you tell me whether or not you want to put O2 analog onto VTR number 2, or are you getting it straight to the ground?
On 2, Owen.
Thank you. You want to command it, or you'd like for me to, Bill? Do it up here. Okay, Mike, we're now going to the zone by spreading here by constant volume separation. And I did inject some extra fluid in here to make a good sized zone, over. Okay, we're still separating the plates now, Mike. said that I injected some more fluid in to make a little fatter zone.
Okay, Byron, that's excellent.
And it's interesting because the fluid on the unwetted plate, Mike, does not spread to the far outer diameter. It looks like it stays about the same diameter on the as the top feeding plate. Over.
That's very interesting. I think that will be of interest to John Saturday as well.
I think so too.
Spacelab marked the lots for Owen. Owen just wants to remind you that STS-09 will be on between 9 hours 50 minutes and 15 seconds till 9 hours 55 minutes and 15 seconds.
Thank you. And the spacelab here for 327 Mike Haynes. Now that I think about it, maybe what happened during the drop is not that the liquid flowed around the edge, but that it seeped underneath between the tape and the plastic plate. There are some little holes there. I wasn't able to get it completely covered up, and it's very possible the fluid just leaked out from underneath. So I think we may not have to worry too much about the fluid creeping over the edge. Over.
Okay, that sounds very reasonable, that it would creep through that capillary space between the tape and the front plate. That's cheerful news, because if it means that you can grow a 90-degree drop, then it gives us a clear go for perhaps another attempt at Isidoro's long cylinder.
Ah, roger. You got the DGP running, CPAC.
Very good, Owen. We're tickled to death. Great. Spacelab, this is CPAC for Owen.
Bill?
Owen, you want to copy the times for the T0 times and the exception monitoring for the MPDR jet firings before on the next pass?
Right now is fine. Go ahead.
Okay, the T0 times will be day 341, 02, 22. The next one will be 0252. The next one will be 0322. And the final one will be 0337.
Sure, I have those.
Exception monitoring. Roger, the exception monitoring will be Sierra 02, Echo 05.
And Echo 05 applies to all four of the preceding operations.
That's correct.
What model number?
It'll be model
one of them.
Roger.
Break, yes, Spacelab here for 327 Mike Haynes. We had a nice break. I recorded it on cine film, and I'm advanced to contact again to join and remove the fluid.
I read that, Byron. Thank you very much. Now, we'd like to maybe go on to see whether you are able to achieve a hemispherical drop, that is a 90-degree angle drop on that end plate. If you can do that, then perhaps you could advance the spreading and do one more spreading experiment for me, and then that will raise Isidora's hopes greatly because he would be able to make his long cylinder if after that you were able to remove my spreading plate and replace it with John Padday's 30mm rear plate. Over?
Yeah, I understand. We'll try to do that. I think what I'll have to do is take it off and redo it with the tape because I need to make sure there's no channel there. Otherwise, I think if the fluid leaks out, it will cause the other fluid to jump around the corner, won't it?
Yes, thinking about it, that is a possibility because it'll have a negative curvature around the back of that undercut.
Okay, let me finish this and we'll think about it a little bit.
Okay, we're thinking down here as well. Spacelab for Byron.
Roger, go ahead.
We've been considering possible solutions to this interesting problem of the capillary creep of the liquid under the plate, and whether or not you can implement this solution depends on the width of the tape that you're using. Can you tell me what width your tape is?
So width of the tape?
Correct.
Well, let's see. I don't know.